Okay, we're doing a derivative approximation now, where it's asking us to approximate the value of 4.05 and compare it to the actual value of 269.04. So we're going to use the approximation that the incremental change of y with respect to x can be approximated by the derivative of y with respect to x evaluated when x is equal to a particular number. Now this is for small changes in x. So going from 4 to 4.05, we can fairly well say that that's a small change in x. So what we do now is we are going to rewrite this in terms of a formula. We're going to use a quartic formula, so we need to write it as y in terms of x. So we're going to use this. So this is going to be rewritten as y equals x to the power of 4. So that's going to give us a dy. Now I'm assuming you guys know how to mechanically differentiate something. So we've got 4x to the power of 3. So if we were to rearrange this approximation formula here, what we're going to get, we're looking for the incremental change in y. So we're going to have the incremental change in y can be approximated by the derivative of y with respect to x evaluated. Now in this case, we're going to evaluate it at something that we can evaluate, x equals 4, times by the incremental change in x. So what we're going to do is we're going to substitute in our values. So this is going to be equal to, so the derivative of y with respect to x evaluated at x equals 4. We're going to put in 4x, which is 4 to the power of 3. So that's the derivative evaluated at x equals 4. And we're going to multiply that by the incremental change in x. Now, you can see that the incremental change in x is this number that we have here, 4.05, subtract where we evaluate the derivative at, 4. Cool. So what we have here is 4 to the power of 3 is 64 times 4 is 256. Multiplied by 4.05 take 4 is 0.05. And if we do that multiplication, we should get to 12.8. You guys can check that if you want to. So with a 0.05 change in x, we're going to get a 12.8 unit change in y. So what we're going to do is our approximation. We're going to get what y is at x equals 4, and then we're going to add 12.8 to it. So our approximation of y, or our approximation of 4.05 to the power of 4, is going to be equal to 4 to the power of 4 add this change in y, which is 12.8. Now, 4 to the power of 4 is 256, plus 12.8 is going to be 268.8. And that is our approximation of 4.05 to the power of 4. Now, as you can see, we're 0.2 out. So we're we're about 0.1% out. So the smaller the change in x, the closer or the less percentage error that you're going to have. But as you can see, for most intensive purposes, this number here and this number here are the same thing. So I hope that helped, and I'll see you again next time.